Hi, my name is Sharon Gorgie, and I am a postdoctoral fellow at Stanford University in the School of Earth Sciences. Global environmental change due to increasing greenhouse gases in the atmosphere has been and will increasingly be affecting crop production around the world due to rising temperatures, more intense storms, changes in rainfall patterns, and increasing carbon dioxide in the atmosphere. Extreme heat during the flowering stage of crops or the reproductive period can be especially risky because any stresses that interfere with pollination and grain formation can severely reduce final yields. In this study, we look at trends in exposure to extreme heat during the reproductive period for 4 of our major globally traded food commodities: maize or corn, wheat, soybean, and rice. These 4 crops together form a large proportion of the human diet around the world. For example, in places like Southeast Asia, where they get 47% of their calories from rice, or in the Middle East and North Africa, where people get about 40% of their calories from wheat. We first pair global maps of harvested area for each crop with estimated sowing and harvest dates and daily average air temperatures from the 1980s through to the 2050s. Historical temperatures are interpolated from weather stations around the globe, while future projections are taken from a suite of climate models. For each crop and location, we roughly identify a 30-day window around flowering and then count the number of days during this period when the maximum temperature exceeds crop-specific critical thresholds and when we expect to see rapid yield declines. With seasonal warming trends of about 0.3 degrees Celsius per decade since 1980, we are beginning to see increased exposure to reproductive extreme heat in certain areas of the globe and for certain crops. For example, wheat in Russia, the Middle East, and throughout Central and South Asia. With future warming scenarios to the 2050s, all 4 crops will see a substantial increase in exposure, particularly in tropical areas. For rice, the primary growing areas in South, Southeast, and East Asia will become increasingly risky. For global area exposed to at least 5 reproductive days over the critical temperature, future projections for maize and rice show large non-linear increases in the coming decades. For example, maize exposure is projected to grow from about 15% in the 2000s to 31% in the 2030s and 44% by the 2050s. With 40% of the global population working in agriculture and feeding all 100% of us, it is critical as a global society that we find solutions to these sorts of challenges. Farmers will undoubtedly find their own ways to adapt, for example, by planting earlier or shifting to varieties that flower at a different time of the season or are more stress tolerant, maybe even switching to other crops altogether. However, these strategies may be difficult in certain regions, for example, in densely populated parts of Asia where farmers already grow 2 or 3 crops per year. To adapt to climate change, we will need scientifically informed planning across all scales of governance in order to help protect food security and farmers' livelihoods around the world.